These are the frequently asked questions for pre-calculus for section 4.3, day 1. We have in exercises 13 to 16, state the sign, positive or negative of A, the sine of t, B, the cosine of t, and C, the tangent of t for values of t in the given interval. Well, after we did this today, I'm sure you don't need this, but I'm going to go ahead and show it to you anyway. What they're saying is, if we think of this as our setup of the XY Cartesian coordinate plane, and we look at the interval that they're talking about, what's going to happen with our trig functions. So for number 13, if we're talking about a triangle that's going to appear between 0 and 2 pi, it's an angle theta that's formed in the first quadrant. And in this quadrant, no matter what side we're dealing with, we're always going to get positive values. So it doesn't matter if we're going to use y over r, x over r, r over r, those are all going to be positive. So for A, B, and C, we would put positives down for number 13. Then, number 14 says, what if we're looking at an interval of pi over 2 to pi? Well, I'm going to draw my reference angle, reference triangle, and reference angle now in the second quadrant, and forget about what I have there as I look at number 14. So for 14, my x value is going to be negative this time. My y is positive and my r is positive. So I'm thinking to myself, okay, anything that deals with x is now going to be negative. Well, sine doesn't deal with x because that's y over r, but cosine does. That's x over r, so that's going to be negative. And tangent is y over x, so that's going to be negative as well. So even without what we just talked about in class today, you can still make your way through these. And that's why, I tend to focus on not memorizing, as being able to reason through and figure out how you would get those. Then number 21 says, choose the point on the terminal side of theta. And if we have a 45-degree angle, when we did this yesterday, we always were trying to use the numbers 1, So with a 45, 45, 90 triangle, normally we think of 1, 1, square root of 2. But that pattern is just an easy way to show ourselves that the relationship between the sides is that we have an isosceles triangle in a 45, 45, 90. So our x and y values will both be the same. And that you find the hypotenuse by taking that side length times the square root of 2. So what we would have to make sure happens in number 21 is that our x and y both have the same values, because that's how we would get a 45, 45, 90 triangle. And that's going to be A. Then for number 22, they have 2 pi over 3. Well, for 2 pi over 3, we want to think of that as 2/3 pi. And think, all right, well, if I had 2/3 pi, I'd go 2/3 of the way. That would leave 1/3 pi left. And 1/3 of pi is really going to be 60 degrees because pi is 180 degrees. So what they're really asking us to do here is look at a 60-degree angle and figure out what those relationships would be for this one. So what you have to remember is that the short side is always going to go across opposite from that 30-degree angle. And the hypotenuse is 2, and we have the square root of 3 opposite the 60-degree angle. So now they're saying, if we do the theta angle of 2 pi over 3, which would be 60 degrees, which of these would represent the relationship between the x's and the y's? And we see here that our x value would have to be negative. So a -1 and a square root of 3 would do that. Now again, just like in the 45, 45, 90, it could be a multiple of that somehow. So let me show you what I'm talking about. It could be that in our 30, 60, 90 triangle, maybe this side is 7. Well, to go from the short side to the hypotenuse, we multiply by 2. So that would make this 14. And to go from short side to long side, we take it times the square root of 3. So there are an infinite amount of numbers that we could use in this situation. And what we need to do is we need to check and see, well, no matter what would the relationship be between our x and y values? And that's the relationship between these two sides. And what we see is whatever this is, we're going to have to take times the square root of 3 to get our y value, and that this one would definitely be negative. It just so happens in this instance that they gave us -1 and the square root of 3. So that one kind of worked out perfect for B in that situation. Next up is number 37, and in number 37 it says we're supposed to find the sine and cosine and tangent for this quadrantal angle. So the first thing you have to do is figure out where is that -450 going to lie. So if we take our -450 and we add 360 to that, we're going to get a -90 degrees. So this is going to go once around and then swing down another 90 degrees. And that means I want to use the quadrantal angle here. The coterminal side with this that would be positive, if we're talking about this angle, would be 270 degrees. And the reference is the same for either one. It doesn't matter. And our point here would be at 0, -1, and we know that our radius would be 1. So here's our x, here's our y, here's our r, and for 37, they wanted the sine, and the sine is y over r, so the sine of theta equals -1 over 1, which is -1. For B, the cosine of theta, that's going to be x over r, so that's 0 over 1, which is just going to be 0. And then for C, they wanted the tangent of theta. And tangent is y over x, so that's going to be -1 over 0, which of course is going to be undefined. Cannot divide by 0. And that is everything from your list.